Hi dear students, how are you? Okay, so we have a new session on Brainiacs Capsule. So again, our topic is electrophilic addition reaction. We have already done 3 videos based on the same topic. You can refer those videos in our playlist. So the focus is after going through these videos, you should be able to do the thorough question that I am expecting one sure short question from this particular type of reaction. So I am sure that it will come from this particular this videos only, because I have tried to take on almost all important questions from this area. Okay, let's try to do this question. So yeah, so we have a new organic compound in front of you and they are asking the HBr addition again. Okay, so you can here also you can see 2 HBr is there. That means there are two double bonds are fundamentally present here. So again 2 times electrophilic addition occurs. Okay, here also I can easily say where the electrophilic addition occur first, because here you have NO2 group and I know that NO2 group has minus M effect. So that means it will pull the electron towards it from the system, from the conjugated system. So that means electron density decreases here in this pi bond. But here if you see, the bromine atom is connected and I know that the halogen atom have plus M effect. Okay, so that will donate electron to the system. So automatically I can say the electron density over here increases. Okay, so I can say the first electrophilic addition occurs across this particular pi bond. Now let's try to see how this happens. All of you listen here. So I have my HBr molecule. What it will undergo first? Heterolytic fission. So you will get H plus and Br minus. So what will happen? Who will approach this bond? I can surely say there is a huge amount of pi electrons that will create a cloud of negative charge in this compound. So H plus with opposite charge will approach this pi bond. That is the reason why, since the first addition happens for the electrophile, we say this type of reactions are called electrophilic additions. Okay. So what will happen, sir? When H plus approaches this pi bond, the pi bond will undergo polarization. Again a question comes, sir, in which way it will polarize? I can easily say it will polarize in this direction. Why? Because when positive charge comes here, you can see positive charge is coming here. The bromine atom, it has a total of 3 lone pair of electrons. So these lone pairs can enter into resonance with this positive charge, making this carbocation stable. And in the next step, what will happen? The H plus will attack the negative charge over here. Okay, so you will get a compound like this. This is my carbocation intermediate. Okay, here the plus sum effect of halogen is also present and also the minus I effect of halogen atom. And please believe, halogens are those compounds, they are the only compounds where minus I effect, I can say the minus I effect dominates over plus sum effect. Minus I effect is greater than the plus sum effect. This is the only type of compound. Normally resonance effect dominates over other effect. But I can say halogens, they are the only species, even though they are orthopara directing due to plus sum effect, but still deactivating. The reason for that is minus I effect is pulling the electron and making the compound deactivated. And plus sum effect, due to its electron donating nature, welcomes the incoming electrophile to the orthopara position. So that's the reason why usually we say all activating groups are orthopara directing. Okay, and all orthopara directing groups are activating. We cannot say that. Why? Because halogen is an orthopara directing group but still deactivating. But all activating groups, if a group is activating, surely it will have what? Orthopara orientation because of its plus sum effect. So the reverse is not true. All orthopara directing groups are not activating, the exception being halogens. Okay, it's a very important question, remember. Yep. So next, what will happen, sir? So the first addition happened, Br minus will attack the positive charge and you will get a dibromo compound like this. The first addition completed. Now again we are taking that compound as my starting. Now again HBr will undergo heterolytic breaking and the electrophile will approach to the pi bond. So again this will undergo polarization. Now again comes the question, sir, in which way it will polarize? You need to try it out, sir. How I can say in which direction? Easily I can say. How means, if the polarization happens in this direction, then the positive charge will come here. Think like that. Positive charge is here, positive charge is coming. Now what will happen? Positive charge single bond and double bond. So we know that here double bond will only polarize in this direction. Why? Because oxygen is more electronegative than nitrogen. So automatically positive charge will come here. I can easily say this positive and this positive will undergo what? Repulsion. So I can easily say that will not be possible. So it will always polarize in which direction? In this direction only. So that negative charge will come here. Now you think positive comes here and a negative charge comes here, means these are also in resonance, making it more stable. Also you can think like you are getting a tertiary carbocation, making it more stable. Now what will happen? The H plus approaches here, will come will attack the negative side, and you will get a carbocation intermediate like this. Now in the next step, the Br minus will attack the positive side, and you will get a compound like this. So this is my final product. Hope you are getting the idea. Okay, idea is very important. So what would be my options are in this case? I can easily say in the denominator part, two bromine atoms are present and one bromine atom here. So the only option that looks like here is option 1 would be my correct answer. Okay, any doubt? Okay, so I will also take another color to mark it if some students are not able to see. Yep. Okay, so I hope you are understanding. So very simple. So always analyze, whenever plus sum groups are there, electron density over there at that particular area increases. Minus sum groups are there, the electron density decreases. Okay, yeah, fundamental is that. Now you have a beautiful question in front of you. All of you please go through that. Now in this particular question, you have CH3 and there is a CH3 here, CH double bond CH2, and you are doing an addition with the water molecule, but the medium contains lot of D plus. The medium contains lot of D plus. Now students may ask a doubt, sir, D plus is present and water ionizes H plus and OH minus is also there. So who will act as an electrophile here? So please understand the medium is made up of D plus. Okay, and only one water molecule is there. So I can easily say the D plus concentration in the medium dominates over H plus concentration. So surely the electrophile would be D plus here. This is the most important thing to remember. Okay, now try to do this question. So you have, listen, so you have the compound present here. Now the molecule undergo ionization here also, H plus and OH minus, but the D plus concentration is more. So what will happen? The D plus will go near to the pi bond. So the pi bond again will undergo polarization. Now again we know that this will polarize in this direction. Why? You will get a 2-degree carbocation in that case. Okay, now again this will check whether it can undergo further more stable carbocation. Before that, the D plus will attack the negative charge, and you are getting a carbocation like this. And please understand, this is a 2-degree carbocation. It will check, okay, if this positive charge is migrated to this particular carbon, you are getting tertiary carbon. But if it is migrated to this carbon, it is primary only. So what it will do, we know that there is a phenomenon that is called hydride shift. This particular carbon has 3 people. One is a CH3, another is a CH3, and another is a hydrogen. So always when hydrogen is present along with the CH3, the hydride shift will dominate. Okay, because hydride is a strong nucleophile, H minus is a strong nucleophile. So it can easily go and attack the positive site. So how that will happen? Listen. The hydrogen with its pair of electrons will migrate towards this particular site, so that the deficiency comes here. So now you see here, this is my alpha carbon, this is my alpha carbon, and this is my alpha carbon. So totally 8 alpha hydrogen is stabilizing this carbocation through which phenomenon? SBH, stabilization through hyperconjugation. Okay. Now I can say what will happen, sir. The OH minus, which is the only nucleophile present in the medium, it will come and attack the positive charge like this. So you will get a compound like this. So this is my final product. Clear? So let's see whether this is present there in the options or not. Yeah, it is there. We can find it out. Okay, so you need to closely see the options. D is present at the edge of the carbon and OH at the second carbon. So we will find out any option similar to that. Yeah, edge of the carbon, this is present, CH at the middle. So I can easily say my answer here is option 4. So you should be very careful, otherwise you will end up in wrong options. Okay, clear? I hope you understood. So let's go to the other important question for the day. The last important question for the day. It is also very important. Okay, now you have here a compound benzene along with a side chain containing pi bond. You have HCl. I can easily say HCl will undergo ionization and form H plus and Cl minus. We know this is the electrophile. Again the question comes, sir, whether this electrophile can attack the benzene. Again the same answer, benzene will not undergo addition. Benzene will not undergo addition. Some students may ask, sir, what will happen then when this H plus will give an electrophilic substitution? No differences are. There is only hydrogen present here. So if you replace this H plus with this H, it will not make a difference. Again, another H plus would be created here. Okay, now let's see. The H plus generated here will approach the pi bond. Let's see the story then. Yeah, I hope all of you could see. Now what will happen, sir? Listen. So the H plus generated over here will approach the pi bond. Again, what will happen? The pi bond will undergo polarization. Now comes the doubt. Sir, will it polarize us like this? Or will it polarize us like this? Please understand, if a negative charge comes here, you are, I can easily say negative charge is coming here and a positive charge comes here. Positive charge cannot undergo any carbocation rearrangement here to become a stable carbocation. But when positive charge is coming here, I can easily say if a hydride shift occurs between this carbon and positive charge comes over here, what will happen? This positive charge gets stabilized by what? Positive charge, single bond, double bond, single bond, double bond, resonance. So in that understanding, I am sure this will polarize us in this direction. So what will happen? A negative charge comes and a positive charge comes here. And in the next step, H plus will attack the negative charge. And you get a carbocation intermediate like this. But I know that this is a secondary carbocation. This can further undergo rearrangement or in a means of hydride shift to create a more stable carbocation by resonance. So checking for rearrangement possibility, and I find hydride shift can occur here. So you can see here in this particular carbon, 2 hydrogens are available, but normally when it is in a bond line representation, they will not show this. You can see this is a carbon in a bond line representation. So carbon has 4 valencies. So 2 valencies are like this, the other 2 are hydrogen. Correct? So 2 hydrogens are there. So one of the hydrogen along with a pair of electrons is called my hydride. It is a strong nucleophile. It will migrate to this positive charge. And what you are getting, sir? So you are getting a carbon with a positive charge near to a conjugated system. So there is a resonance, positive, single bond, double bond, single bond, double bond, single bond. So it is stabilized through resonance, I can easily say. So next what will happen? The chlorine nucleophile, which is a nucleophile present there, will attack the positive charge. And what you are getting? So you are getting a product like this. You can see the chlorine nucleophile is attacking the positive charge and you are getting a product like this. I hope you understood. Correct. So what would be my answer, sir, in this case? You can easily say, looking at the options, option 4 would be my correct answer. Okay. So I can easily say option 4 would be my correct answer. Clear? I hope all of you understood this class. Okay, if you have any doubt, feel free to put it in the comment box. You can consider subscribing our channel, and you can also watch the playlist, the various strategies that is important for NEET, the various important questions that is important for NEET, everything we are discussing. The upcoming sessions, we are also planning dissecting the NCERT. We will dissect the NCERT line by line, and also we will include questions along with the NCERT so that you can go through one section and also you can attend the important questions from that area. That is upcoming in our tutorial. So please subscribe the channel to watch all these videos first itself. Okay, thank you.